Part B, example 2, we're still with lesson 3. We want to find the derivative of a square root of x. So this is going to be a little different. We're still going to do the limit process. But let's see what happens. So I've got the setup here already. We know with the limit, we want the average rate of change. So f of x plus delta x minus f of x all over delta x. We've seen this before, right? So we break our pieces down. We know what the x plus delta x should look like. We know what f of x should look like. So before I take the limit, this is what I get. I get radical x plus delta x minus radical x all over delta x. Now we know in the other problems, the goal is to really get rid of the delta x because you want the limit as delta x goes to 0. So we need to think back to some of our Algebra 2 trig in our pre-calc, and how can we manipulate this current expression to our advantage? So let's try the conjugate, multiplying by the conjugate. So let's try that out and let's see if it gives us a little bit of an advantage. So we're going to copy this here. I'm going to paste it, and let's work with this. Let's see what happens. So if we multiply with a conjugate, then we're going to multiply by radical x plus delta x plus radical x, and we're going to put that over itself. Radical x plus delta x plus radical x. So the goal when we do this, if you remember when you multiply by the conjugate, is that you're generally going to keep the first and second term but squared. So if you need to see a review on that, definitely Google multiplying by the conjugate. This is not that time. We are in calculus. We are not in Algebra 2 trig, so Google that on your own. But when we do multiply this, the radicals will cancel out. So now I'm going to have an x plus delta x minus x, and in the denominator, I'm going to have delta x times x plus delta x, all under a radical, plus radical x. So if you get what I did, awesome, keep watching. If you don't, pause the video, rewind, and watch back as to what I did. Nothing of what I just did is calculus. None of it. It is Algebra 2 trig, pre-calc, multiplying by conjugate, okay? So again, if you don't know what I just did, back up, rewind, and see if you can review the material. Now we're going to continue. Our goal again is to get the derivative. So let's put that together. The limit as delta x goes to 0 is what we're looking for. Right now, if I multiply this by 0, it's going to be 0 times the denominator, which doesn't help me out. So we've got some simplifying to do. So we've got x and x here, which now gives me an opportunity to have delta x all over delta x with what was left over because of the conjugate. So it works out pretty nicely. Those guys are gone. I rewrite my limit one more time. The limit as delta x goes to 0, but now I'm left with 1 over x plus delta x square root plus radical x. Okay, now let's try it. If you substitute in the 0, what you're going to get is 1 over x plus 0 radical plus radical x. Because remember, when we substitute in this limit, we're only substituting 0 for delta x, so the x's stay the same. And if we simplify this, we get 1 over radical x plus radical x, and when we have 2 of something, we call that combining like terms, so we get 1 over 2 radical x. So this is how we complete a problem that has radicals that we need to apply the limit process of the derivative. Let's say that I'm unsure of my answer, right? So remember, we can always check our work because we know the power rule. So let's try the power rule. Let's check our work. So if I apply the power rule, I started with f of x equals radical x. According to power rule, we need things to be in the proper form. So I can't get it yet until I rewrite this. So I rewrite this as f of x equals x to the 1/2, which you know because of pre-calculus and Algebra 2 trig, And now I can apply the power rule, which says multiply by the exponent, keep the variable, and subtract by 1. So 1/2 minus 1, or 1/2 minus 2 over 2, is negative 1/2.
And if we simplify that, ladies and gentlemen, we get 1 over 2
radical x, which means we got the right answer. And our check proves it.